Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5. It says, learners used the investigation of a sodium thiosulfate solution with dilute hydrochloric acid to investigate several factors that affect the rate of a chemical reaction. The balanced equation for the reaction is as follows. So we can see right there. And then 5.1 says, define reaction rate, right? So what is reaction rate? We are going to say, again, the change in the concentration of the reactants or products per unit time, right? So we are always expecting that definition as our first question right there. Then 3 investigations, 1, 2, and 3 are carried out. Investigation 1, the result obtained in investigation 1 are shown in the graph below. So this is a graph of reaction rate versus concentration of the sodium thiosulfate. For this investigation, write down the dependent variable. Now we know the dependent variable is the one that will be found on the y-axis, right? So our dependent variable is the reaction rate. And then as we always know with this investigations, our dependent variable is always the reaction rate. And all the factors that affect the reaction rate are your independent variables. So your independent variable in this one would be the concentration. Now 5.2.2 says conclusion that can be drawn from the result. From here we can see that this line here or this graph represents a directly proportional relationship between these two, right? But then please don't write that you see that it's directly proportional. You need to explain the relationship. And how do you explain the relationship? You need to actually explain. It's more like explaining what do you mean by saying directly proportional. Remember, if you were to call someone who is not well versed in that knowledge, they wouldn't understand what you are saying. So the goal in writing a conclusion is to make it understandable to everyone else, right? So reaction rate increases with an increase in concentration. You see, this one is very simple and straightforward, and everyone can understand that. Everyone would be able to tell that, oh, as the concentration is increasing going to the right, also the rate of a reaction is increasing going upward. So reaction rate increases with an increase in concentration. There we go. So make sure that your explanations are always so simple to understand.
Haya sasa watu wapo kazini. Kazi endelee. Nisisemi, najua wenyewe.
Okay, so now we have 5.3 says investigation 2. The Maxwell-Boltzmann distribution curves A and B below represent the number of particles against kinetic energy for the reaction at 2 different temperatures. So this is indicating temperature. And as we can see, this other graph has shifted more to the side there, which will be indicating an effect of temperature. So 5.3.1 says, what does the line P represent? The line P here represents what? Activation energy. Activation energy. And then we have 5.3.2 says which curve A or B was obtained at the higher temperature. Which one was obtained at the higher temperature? You just have to look at the area under the graph after point P there. So we can see that the one that is a larger area under the graph is graph B. So that means this is the one that indicates a higher temperature. So it would have to be B. Now 5.3.3 says explain in terms of the collision theory how an increase in the temperature influences the rate of a reaction. Again, you have to explain fully. So this is how you explain. And then at a higher temperature, you say, at a higher temperature, when you increase temperature, at a higher temperature, the average kinetic energy of the particles increases, meaning that there will be more particles will have sufficient energy to collide, and then resulting in more effective collisions per unit time. Resulting in more effective collisions per unit time. And then your final nail to the coffin. Thus, the rate of reaction increases. There you go. Right. So 4 marks, full explanation. At a higher temperature, the average kinetic energy of particles increases. More particles will have sufficient energy to collide, resulting in more effective collisions per unit time. Thus, the rate of reaction increases. And that's just how you are supposed to explain that.
I'm saying, and I say this without any fear of contradiction, we are cruising nicely.
Right, so 4 marks in the bag, just like that. And then 5.4, we now have investigation 3. So let's erase this. The potential energy diagram X and Y below represent the reaction under 2 different conditions. Give a reason why curve Y differs from curve X, right? Okay, so for 5.4, we can see that here, this is a what? This is a potential energy graph, right? And then we know that once we have that broken line there being below, it simply means that in this reaction, in this other reaction here, there was a catalyst that was added. So for 5.4, we are going to say curve Y was obtained for the reaction with the presence of a catalyst, and X for the reaction with the absence of a catalyst. With the absence of a catalyst. So one was obtained at the presence of a catalyst and another was obtained at the absence of a catalyst. So Y here has a lower activation energy because, as we can see here, a catalyst was added. But the other one still has a higher activation energy because no catalyst was there, right? So this one, no catalyst. This one, yes catalyst. Then in 5.5, they say in one of the investigations, so let's erase here. In one of the investigations, 100 centimeter cube of 0.2 mole per dm cube hydrochloric acid reacts with excess sodium thiosulfate, and the solution is then filtered. After filtration of the solution, 0.18 gram of sulfur is obtained. Calculate the percentage yield of sulfur. again, you can see that it's taking us back to grade 11 stoichiometry. So again, I am telling you, you will need to have a relationship with your grade 11 stoichiometry in order to survive these questions right here. Okay, so now if we can just go back to our balanced equation and just copy it here. So we have sodium thiosulfate reacting with hydrochloric acid to produce 2NaCl plus SO2 plus sulfur plus H2O, right? Okay, then we can go back now. Right, so this is what we have. Now understand with stoichiometry, step will be given information on one thing, and then now we have to use that to find the information that we are looking for. So we are given hydrochloric acid, which is said to be what? Reacts to be the limiting. So they did not really say it, but then they said this one is in excess. Now, if this one is in excess, then obviously this one has to be the limiting reagent. And if we want to find about the products that are being produced, we know that the limiting reagent is the best one to tell us about that, right? So note that in grade 11, I used to say that you use your limiting reagent to find the percentage yield, right? So if you want to calculate the percentage yield, you always have to calculate it based off of the limiting reagent. So step number one when calculating percentage yield was to first, obviously, calculate the number of moles. Calculate the number of moles. So consider this your revision of stoichiometry, but then you'll still need to do a proper revision of that. So calculate the number of moles. So this is going to be what? We are given concentration, we are also given volume. So the number of moles would have to be calculated using this formula here. So number of moles of what? The hydrochloric acid. So it's C multiplied by V. Our concentration is 0.2, but once again, our volume is given in centimeter cube. So we know from cubic centimeters to cubic decimeters, we need to divide by 1,000. So it's going to be 100 divided by 1,000, which is going to be 0.1 cubic decimeters. So we put it right here. Then you obviously need the aid of your calculator. Then you're simply just going to say 0.2 multiplied by 0.1, which will give you 0.02 mole, right? So that's the first step. You have calculated the number of moles. Step number two from your stoichiometry is to use the molar ratios. Use the molar ratios. Now, what are you going to do now? You're going to say, I have this, but I'm looking for that. I'm looking for sulfur, right? So this is what you're going to do. Ratio of hydrochloric acid to the ratio of sulfur. Hydrochloric acid, for every 2 moles of hydrochloric acid that reacts, there is 1 mole of sulfur that is produced. So how many moles of sulfur will be produced using that ratio? This is 0.02. And then this is x. So we need to cross multiply here. This will be 2x is equals to 0.02. Divide by 2 both sides. Then our x will be equals to what? 0.02 divided by 2. This will give us 0.01 mole. Of what? Of sulfur. So sulfur S. Then, okay. Now, obviously, to calculate the percentage yield, we then have to calculate the mass. The mass that we are calculating here is what we call the theoretical yield, right? So the mass that we are trying to find here is theoretical yield. So step number 3 is to calculate the mass. Calculate the mass, which is what? The theoretical yield. The theoretical yield. Okay, so this will be M N multiplied by M. So our number of moles is 0.01. And then what's the molar mass of sulfur? Molar mass of sulfur is 32. 32, I believe so. And then this is going to be what? 0.01 multiplied by 32. And then we get 0.32 gram, right? So this being our theoretical yield. But then remember, how do we then calculate the percentage yield? So to get percentage yield, we need to say the actual yield over the theoretical yield and then multiply that by 100. So actual yield over the theoretical yield. Allow me to write it here. So percentage yield is actual yield over theoretical yield multiplied by 100. So you will remember that from your grade 11 stoichiometry. And then now we need to do what? We need to then say our actual yield is what? 0.18. So this is what we get after filtration, the actual one. So 0.18 gram. Now the bigger one is always the theoretical yield because this is just only based on calculation. It is not the actual experiment taking place. So it makes sense that we will always theorize to have a bigger value than what will actually be produced. Then multiply by 100. And then this is going to be 0.18 divided by 0.32. Then multiply that by 100. This is going to give us what? 56.25. So 56.25%. And right there, ladies and gentlemen, that's how you calculate your percentage yield.
It doesn't need chance takers. It doesn't need people who like nice time, niceties. It doesn't need that. It doesn't need people who get shaken easy.
So make sure that you follow those steps. Number one, calculate the number of moles. Number two, use the molar ratio in order to calculate the number of moles of the one that you are looking for, which is sulfur. Then use that to calculate the mass of the sulfur, which is now the theoretical yield. Then from there on, your step number 4 is just to calculate the percentage yield. So to calculate the percentage yield, which is what you're looking for. So you follow those 4 easy steps, then you'll be able to calculate that. Right. So, okay, make sure that you come back to this video, watch it as many times as possible, and just try to understand the approach that I took into solving all these questions here. But then with all that being said, press that subscribe button, press that like button if you have enjoyed watching this video, and do not forget to share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.